Hello, students. Here you see a number line, much like an integer line that you might see in math class. We are in meters. This is the positive direction. And unlike math class, where things don't really represent anything in the real world, this number line would represent physical locations on the earth. So maybe this would be your classroom door, and this would be walking towards the gym. So don't be confused by this negative. It doesn't mean you're moving backwards. It just means you're moving in a direction that is what we have decided to call negative. And instead of using left, right, forwards, backwards, north, south, east, west, we use numbers because they can easily be translated onto a graph. So this doesn't represent an integer, really. It represents an actual spot on the floor of the hallway. So remember the displacement definition. And we have ending spot minus starting. Maybe you could think of it as final spot minus initial or starting spot, or first spot minus 0th spot. Sometimes you'll see it written this way. So let's start with our first example. In this first example, I'm going to give you some rules, and then I'm going to ask you to pause the video and see if you can figure out a certain way to move so that those rules come true. So the first rule is that you have to have a positive displacement, and you can't start at the 0 meter mark, and you have to move more than 6 meters. So pause the video and see if you can figure out a way to do this. Pause it now. Okay, you're back. So there are a lot of options here to have a positive displacement. You can't start here, and you have to move more than 6 meters. So let's just say you start at the 2 meter mark. This would be your x1 starting spot. So you could go 2, 4, 6, 8, and you could end here. This would be your x2. So x2, 10, minus x1, 2, gives you a value of 8 meters. And notice that when you end, you are more in the positive direction than where you started over here. So that makes it a positive 8-meter displacement. Another option is you could actually start here, and you could move more than 6 meters by going 2, 4, 6, 8. So that's 8 meters of distance that you traveled. Doesn't matter that you went backwards because distances are always positive. So you started there, you ended there. X2 is 10 minus x1 is 6. 10 minus 6 is a difference of 4 meters, and that is also a positive displacement. If you want to get really strange, you could start here at -4, and you have to move more than 6 meters, so you could go 2, 4, 6, 8, 10. You started here at -4, you ended at -2. Your x2 value is -2 meters. Your x1 value is -4 meters. -2 minus -4 gives you a positive 2. So you started at the -4, and when you're done moving at the -2, you are more positive than when you started, so your displacement is positive. So if I were to ask you to do the same thing, but with a negative displacement, you could start where you want. You could start here. And all you have to do is move in such a way that you move more than 6 meters and that you end somewhere over here in the negative direction. So you could go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. And you could end there. And this would also be a negative displacement. So let's try a third example here. So I want you to move in such a direction and in such a way that you have a displacement of +4. And I don't want you to start at the 0 or the 4 meter mark. And you have to move more than 6 meters, and you must move in the negative direction at least once. So pause the video and see if you can figure this out. Okay, you're back. So pick a starting location, maybe here. You have to move more than 6 meters. You have to move in the negative direction at least once. And you can't start at the 0. You can't start at the 4. And you must be 4 meters away from where you started when you're done moving. So maybe you could start here you could go 2, 4, 6, 8. So you've moved more than 6 meters. You moved in the negative direction at least once, and you ended at 6 meters. You started at 2, x2, 6 meters, minus x1, 2 meters, gives you a displacement of 4 meters positive. And again, you are more in the positive direction here when you ended than you were when you started. For our fourth example, I'm going to give you one, and I want you to figure out the distance that I traveled and the displacement. So we're going to start right there, and we're going to go like this. 2, 4, 6, 8, 10. Pause the video and see if you can figure out the distance traveled and the displacement. Okay, you're back. So you started here, you ended there. And if you remember, I moved a total of 10 meters. So that's your distance traveled. This is your x2, negative 6 meters. This is your x1, negative 4 meters. Negative 6 meters minus negative 4 meters gives you a value of negative 2 meters for your displacement. Okay, here's an example for you baseball fans. This is one of the most incredible home runs in the history of baseball, 1975. This is Fenway Park. It's the middle of the night. The game is tied. It's Game 6 of the World Series, and it's the Red Sox versus the Cincinnati Reds. And this is Carlton Fisk, and he hits a home run that bounces off the third baseline foul pole, and that's a fair ball. And the Red Sox ended up winning Game 6 and then got flattened in Game 7, and the Cincinnati Reds won. But you'll see him bouncing down the first baseline, yelling to the ball to go fair. And you may have seen this footage. It's one of the more popular scenes in the history of baseball and our culture. So it's 90 feet between each base. I want you to figure out the distance he traveled and the displacement. Pause the video now and see if you can figure it out. Okay, you're back. So if you give home plate a number, I think it would be wise to call it 0. And because we're doing feet this time, home plate would be represented by the number 0 feet. And if he runs to first base, that first base would be called 90 feet, and then so on around the bases. So he's going to run 90 to first, another 90 to second, 90 to third, and 90 home. So he travels a distance of 360 feet. But he started where he ended, home plate. So his displacement is 0. And now, just because baseball is awesome, I'm going to show you a couple other great moments in baseball. If you're not interested, you can move on to the next review video. But this is Kirk Gibson in 1988, and what you need to know is that the Oakland A's were unstoppable and extremely difficult to beat. They simply crushed everybody that they played. And this is Game 1 of the World Series in Los Angeles. And this is the 9th inning, the bottom of the 9th, and the Dodgers are losing by 1 run. And this is the Oakland A's best closing pitcher, Dennis Eckersley, and very few batters could actually hit the ball at all when he threw it. He was that good. And they bring this guy out, Kirk Gibson, who's their best home run hitter. But Kirk Gibson is so injured that he wasn't even in uniform at the beginning of the game. So they bring him on in the bottom of the 9th, put him in a uniform. He hobbles out, and you'll see here on the taskbar that his at-bat before this moment I'm about to show you lasted 6 minutes and 30 seconds. if you want to Google it and watch the true at bat, it's definitely worth it. I think he probably hit like 10 million foul balls before this happened.
Sacks waiting on deck, but the game right now is at the plate. High fly ball into right field. She is gone.
This is simply known as the Gibson home run to baseball fans. And the Oakland A's never really recovered from this moment, and the Dodgers won the World Series in 5 games. Here's the last one. This is back when baseball was really cool. 1976 New York Yankees. And this guy hits a home run, a walk-off home run, and just watch the place go nuts and watch the fans.
He hits one deep to right center. That ball is out of here. The Yankees win the pennant. Holy cow, Chris Chambliss on one swing. And the Yankees win the American League pennant. Unbelievable, what a finish. As dramatic a finish as you'd ever want to see. With all that delay, we told you Littell had to be a little upset. And holy
There you have it.
Chambliss hits one over the fence.
And we're going to move on to a new review video in a moment.
And this field will never be the same, but the Yankees have won it.
If I can figure out how to stop